is 1.05, which is about repeated percentage change. And we're going to do example 12. Now what this is about is helping you to understand that if I increased something by say 10% and then I increased the answer by another 10%, that isn't the same as having increased the first amount by 20%. You end up with a different answer. So when you get questions which ask you to say, you know, and it's the same with a discount. So when you get questions that ask you to discount something by a percentage and then discount it again by a percentage, you don't just add the two percentages together, okay? Because you get the wrong answer. The repeated percentage change. So in here, so for example 12, it's saying what percentage change is equivalent to a decrease of 15% followed by an increase of 13%. Okay, what is that? What is the actual percentage change as a result of that?
Do we want it in like the total percentage increase or decrease?
It's going to end up being a very slight percentage decrease. So I think the way to do this is to start with 100. Okay, we're going to start with 100 there. And then we're going to decrease 100 by 15%. And so if we multiplied 100 by 1, and you'll notice that I do things sometimes a little bit differently from the examples. If we were going to keep 100 at the same, we'd multiply it by 1. But we're not, we're going to decrease it, so we're going to subtract, and we're going to subtract it by 15%. We're going to decrease it by 15%, which is 0.15. So if we go 100 times 1 minus 0.15, that will be the same as 100 times 0.85, which will come out as 85. All right. So now, having decreased it by 15%, we're going to increase the answer by 13%. So we'll start with 85. If we multiply it by 1, it stays the same, but we don't want to multiply it by 1, we want it to go up. We want it to go up by 0.13 or 13%. Okay. So that's the same as 85 times 1.13, which should come out at 96.05. It'd be great if someone would check that on their calculator. Thank you. Okay, so if we started with 100, we dropped it by 15%, we got 85. We then increased it by 13%. What's the net change there? What's the ultimate impact on 100? Well, 100 has gone down by, 100 has decreased by 3.95, or 3.95% off the original. So that proves what I was telling you in the beginning, because remember where I started? I said, well, you can't take a number, increase it by 10%, and then increase it by another 10% and expect that it's gone up 20%. It will actually have gone up more than that. Okay, here we've decreased something by 15%, increased it by 13%. Intuitively, you might say, well, that's a decrease of 2%. No, we find out when we run the maths through, it actually comes out as a decrease of 3.95%. Okay, can you stop the thing?